In this video, we'll review significant digits. Significant digits are used to communicate the precision of your answer. The number of significant digits that your answer will have will depend on what mathematical operation you're performing. Let's take a look at an example. For multiplication and division, the value with the least number of significant digits determines the number of significant digits in your answer. In the example for multiplication, we see the forces being calculated. We see that the mass is multiplied by the acceleration. For the mass, this value has 3 significant digits. For the acceleration, we see that this value has 2 significant digits. So what you need to do is multiply those numbers together and get your unrounded answer. Now we know from the rule of multiplication and division for significant digits, the number of significant digits in your answer is going to be the same as the number with the least number of significant digits that you used in the calculation. So this value here had 2 significant digits, so we round our answer so that it also has 2 significant digits. Let's take a look at an example for division. The same rule applies. We're figuring out what the speed is, and we've got the distance and we've got the time. We see that the distance is 35.34, which has 4 significant digits. The time has 9.2 seconds, which has 2 significant digits. We get our unrounded value right here, and we go with and need to round our answer so that it has the same number of significant digits as the number with the least number of significant digits used in the calculation. Since that is 2, our answer also has 2 significant digits. Let's take a look at the rules for addition and subtraction. For addition and subtraction, the precision as shown by the number of decimal places in the values being used determines the number of significant digits in the answers. That sounds a bit confusing, so let's see what they mean. So in this case, we're finding out what the distance is. We've got 11.2. 11.2, this value has been measured to the 10th. So it's not super precise. The 10th measurement is okay. It's being added to 13.43. We see that this has been measured to the 100th, so it's a little bit more precise than the previous one. And 15.678, that value right there, that has been measured to the 1000th, so that's the most precise value. Now, when we're adding these values together and we're stating our answer, we need to state our answer with the least amount of precision that was used in the calculation. So since 11.2 was measured to the 10th, and that is the least precise value, it's only been measured to 1 decimal place, our answer also is stated to 1 decimal place. So again, we get that unrounded value. We round it so it has the same amount of precision as the least precise value used in our calculation. For subtraction, we're going to use the same rules. We've got this value of 30.624. This value has been measured to the 1000th, and it's being subtracted by 2.98, and this has been measured then to the 100th. So we get our unrounded value, and since the 100th place is less precise than the 1000th place, our answer is going to again be rounded so that it is expressed to the nearest 100th. So the last thing that we need to go over is the rules for zeros for significant digits, because they can get a little bit confusing. Let's review those rules. Zeros appearing anywhere between 2 non-zero digits are significant. So in an example here, we have the number 101.1203, and it has a couple zeros in it. The rule states that if these values are between non-zero values, they count towards significant digits. So in this case, all of these digits are significant, and that would be measured with significant digits and have 7 significant figures. Sometimes we say figures, sometimes we say digits, it's the same thing. The next rule is the one that confuses most students, and that is that leading zeros are not significant. So for example, if you have a value like 0.00052, this only has 2 significant figures, and that's because these leading zeros, or the numbers that are out in front of those non-zero values, they don't count. So I'll write that down, and it's a little bit messy, but they don't count towards your significant total. So in this case, this value only has 2 significant figures. Now trailing zeros, they are containing a decimal point, they are going to be significant. So if we look at an example here, if we have 12.2300, since these are trailing zeros and they're after a decimal place, These values do count towards significant digits, so I'm going to write that down. They do count, and therefore this value is going to have 6 significant figures. Now the next example is a little bit of a tricky one. It's 0.000122300. We just learned that leading zeros, they don't count, but these ones back here, the trailing zeros, they do count. So when we're figuring out how many significant digits this value has, it's going to have a total of 6. The 1, 2, 3, 4, 5, 6 significant digits. The only other thing that we'll see in this course, and a rule for this course, is if you're given some value like 10 newtons, this is considered to have 2 sig digs. And if you're given a value like 100 newtons, this would have 3 sig digs. Some courses say that you have to have a decimal place after that value for those zeros to be significant. That's not the case for this course. 10 would have 2 sig digs, and 100 would have 3 sig digs. I hope that helps. If you have any questions, please contact your instructor in private discussions.